so that all the students join in. Okay, I'll start the session. So, action items for the today's class. Uh, in the last class, I have given an assignment for operator overloading, and uh, most of the students thought it's a easy one, but it was a tricky one. It was not a difficult one for sure, and got to know that students wanted a deadline to be extended. Um, Usually shouldn't happen, but yeah, considering for the first time, I did extend the deadline for 24 hours more. So many of the students have done the assignment, and it's okay. I mean, things are good. Let me quickly check the, the classroom link. Meanwhile, let me share my screen also. Hope first of all I'm audible, right? Yeah, great. Yeah, I have some technical glitches, unable to share my screen. I will quickly join it. Sorry for the inconvenience. Yeah, I have joined back. Let me share my screen. Uh, Now, yes, I'm able to share my screen. Hope my voice is audible and my screen is visible. Okay. Yeah. So, as per the today's action items, uh, definitely we'll look for the assignment solution. Many are did in a way it works, but can be done in a better way. That's my whole point. We'll see that what is that better way. And in the last class, we did see an example, mm, shape and rectangle. We try to modify at the end. Now, last couple of minutes, and some problem was there definitely, and that's why the garbage value was coming for the rectangle class. We will try to calculate the area of a rectangle, and we got some garbage value. We'll see that what was the problem all about. I will continue from the class where we left out, right? So now let me open the programs. Function operator overloading binary it was, right? So this was the an example which we modified from having a combined marks from student to report, and I asked students to extend this, amend this code so that it works for uh, more than two operands, but we'll stick to three. So yeah, what I will do is I'll do some quick changes. Okay, just concentrate. Those who are already done in a different way, it's okay. It's okay, but this could be a more readable and easy way of doing it. Uh, so right, okay. So this is the operator which has been declared here, and I defined it here. So what I'll do is uh, all something I want, like okay, I will take one more object of students. Say I will make, right. So yeah, this is pretty clean. Everybody understood, I guess. So what I will do is k dot mm, name equal to Ram, okay, and k dot marks equal to some 91 probably. Yeah. So definitely I want to print what uh, k has. K dot print. Till then, I don't think any student faced any difficulties. So I want something like mm, s dot p dot sorry, s plus p plus r. So in case right now it is three objects. Even if I want something like, oops, it's not r, it's k. Sorry for that. Then probably l, m, n, something like this. It should work also. But many of the students realize this doesn't work like that. So here is the catch. It's all about the approach. What I will do is I will define uh, here itself report type, uh, return type, and operator. I will declare and define here itself operator. Now plus I will take a student takes always. Okay, right? Make sense? Huh. So whenever this is called, so I will make it to mm, a zero initially. Whenever the report object is called, I just want to make combined marks is zero. So oh, so what to do is I'll just add uh, directly write return. I have write marks, or probably I will for better readable purpose. No, report say report Z uh, Z dot. No, it will be a separate copy. I don't want to do this. I will come back. Just do a return. Yeah, could be in a better way also, but yeah, right now com underscore marks. Definitely class report can access combo marks. Oops. Marks plus x dot marks, right? Oops. Yeah. Make sense, students? But I don't want here. I don't want a double. Okay. Definitely I don't want. Many of students have done that. That should be okay, but I don't want here. Mm, okay. So it will return uh, this whole. No, I have to define for sure. Sorry again. Report Z and Z equal to yes. We'll, we'll make Z dot com marks. So is this clear till now? And I have to definitely do a return. Return Z. Hope this is clear as of now. Now comes the tricky part. Simple thing. Very simple thing. I have removed the plus operator overloading from student. So how can this be achieved? So what I will do is I've taken an object called R. I will do something. Let me know whether this works. Right? I have added the marks of student S. Then again R equal to R plus P. Right? R equal to R plus K. Right? And I can do similarly like R equal to R plus L so on. So I can add as many number as possible. We'll try to print S dot print K dot print also and R dot display. What is R dot display has combined marks. Perfect. Okay, we'll see will this works or not. So what I did, first we'll try to see the result. If required any modification, then we'll modify it and we'll conclude like how it works. Yeah. G++, hope it runs. Binary. Oops, so many error. Definitely there might be some. Okay. Student X return Z. Yeah, there is a small mistake. Right. Uh,
Sir, in main function also there is some mistakes.
oh, is it? Okay, okay. Let me see that.
K dot name. After run, there is no semicolon, sir.
Very good. Correct. We'll try doing this. Binary. Still, it got student has not been declared. Okay. So, this is a what beautiful learning. So, uh, we can see that first we defined report. In report, we are trying to look of student, but student is not yet defined because the compiler starts student's definition after here. So what I'll do is I'll just quickly cut this part and I will define here, right? So now when compiler starts, compiling from line 1, first the this part is getting defined, compiler understand, then definitely this should able to pick it. I hope so this works. Clear screen. Perfect. So okay. Head dot out. So we can see that that added properly 88, 92, and 91. So almost 90 and on average plus 1. That is 271, right? We nicely able to get all the student marks and keep appending to report class. So now we'll slowly check the program what we did. Initially we just have student and main program. So we try to add that both these, we took two objects s and p, and we try to add these values and try to keep it, to try to store the overall marks. When we use s plus p, the value was stored in s object. If I use p plus s in that operator overloading function, yes, all these programs are realized in operator overloading function, and in this example it was plus. So with this plus, it was trying to keep in the first operand, right? So we didn't wanted to do that. So we shifted that concept of having overall marks in rather than students. We wanted to keep in report. So a report class has been introduced with a minimum time we are able to implement, and we pushed the combined marks from student to report class, and then we try to solve adding two students marks, respective marks, and we could able to see that also. Now using that we wanted to extend, definitely students won't be in a college or in one particular department, there won't be only two students, will be definitely more. So if I want to generate report, so should be able to do more than two operands. So how best we can do it? So when I said more than two operands, everybody, I mean including myself also. So I wanted something like this, yeah, like s plus p plus k plus l and so on. When few students did the approach of using arrays and all, uh, yes, this thing can be achieved in so many different ways. Like few of the students did something like s plus p and then again r equal to r plus k, right? So in this case the plus operand will be called from student class because both the operands are of type student. But in this case, uh, there is one more plus operand function is written in report. It takes uh, input of type student and it adds. So this is also okay. Like so many ways we can write it, but as I said, we want to do it in a simple, nice way. So in that sense, I just had only one overloading operator overloading function for binary plus operator, and we could able to achieve in in no time, right? So uh, changes looks
Sir,
yeah,
sir, in this method also we can directly use r equals to s plus p plus k, sir.
r equal to s plus p
P
plus
plus
k.
k. In this
Huh.
one also, sir.
Yeah, because let us try that also. So I haven't tried that. Right now, I will comment this r equal to s plus right k, but I want to do this first, right? Something like this you're saying? I don't.
No, sir. R equals to s plus p plus k, sir.
R equal to s plus p plus k. Okay, okay. Will s plus p plus k like this? This can be done.
Yes, sir.
We'll see that. because the first operand it expects it's I have my own clear. Okay. Mm, this doesn't work. I have the doubt. You know why? Mm, why this doesn't work or probably throws a compile error? Mainly because so this plus is an operator. It has a special meaning also. Plus usually does an arithmetic operation. When compiler comes and try to decode all these, what the definition, what reference, how many memory has to be created for what objects, etc., etc. When it's try to look for plus for non-primitive data types like an object, it looks for yes and p. So in this, the plus which has been written, right? The plus now it has been written in where the plus special meaning or a new form is written under report. So in this report, I have that uh, definition for plus operator. That is, this is the operator overloading function. Function is been defined for operator plus. So when this
Sir, but for student also we need a student overloading operator, na sir, in student class also.
if we have student there also, then this works. Okay. So what? Yeah, I have seen couple of examples which students have done. That's a one way of doing it. So basically,
Sir, uh,
just a
I guess
just
if
a
we'll
second.
write like R equals to R plus A S plus P plus K, then it will work, I guess.
Yeah, yeah, yeah. So something like if this, we'll see that uh, it worked. Oops, I will hide this. So see R plus because I just want to one plus special meaning operator overloading and that I want to be in report rather than in student. So the idea of the scenario is I want to add all the students marks and I want to keep it in report. So with better I should have this special operator function, the operator overloading function in report rather than student because it's a extra line of code. It does the same. It hardly doesn't matter for a compiler whether it takes first it will do a addition of two student objects and then the from next on like third, fourth, fifth, sixth, it takes on adding one report and other is student, right? So compiler it hardly matters because it this whether we write that operator overloading function in not just the student but also in report or not just in report but also in student, the execution, the number of code getting executed at compiler level is the same, but however for the programmer it looks tedious. So like I have an operator overloading function at student also and at report also. If I write that and someone comes and sees, wow, why he has written at both levels. So for easy readable, what I did is I, modified the operator overloading function, moving from out of student to report at report level, and every time it only looks for student and returns report. So by this we could achieve any number of uh, additions of mm, objects, right? Objects. This is one scenario. Hope things are very clear for the students. Any questions now can ask, or any messages also is fine. If it is completely clear, just drop a message in the chat box so that I can continue. Great, I can see two. Yeah, as one of the students pointed out, let me go to the, yeah, having this operator overloading function at student level as well as report level, it works, but uh, it's not so, it is readable for sure in this scenario, but when we extend, when we try to do this concept, or we try to extend this concept in a bigger picture, and there is so much of code is going on, and we hardly able to trace back that time unnecessarily. Having two different operator overloading functions at two different class will might give a confusion, and probably doesn't sound clean or doesn't sound perfect. So what I did is I just moved from student to report, so that only one function is good enough to do all the necessary things. The trick was just moving here and making the initial value to zero, so that it keep adding to the same variable. At the end we can display that, right? Now I will close this program. So right now, this is the in a detailed way of explaining like how it works. It always takes an first operand R, and it takes the second operand student, and that's why we in R the student input, and it adds student and keeps it to again same R. So this is a clear way of understanding, but yeah, this ultimately this will be executed and it is replaced with now again an R. So it will be something like, first time it will be in this way. So RS is being replaced, it gets executed, plus comes, gets executed, and again it is replaced with R. And then again RP is called, P is student type. Again it calls, again it is replaced with R. And RK calls, it assigned to R, and finally we print it. This is how it internally happens. So by doing this, we could achieve without any glitches, like L, M, and so on. Right? So it was a very easy thing, I felt. But if we miss this R, then we will uh, end up in so many errors, because we are not defined for handling S plus P and further so on. Correct. So, and one more thing, important thing, we saw that if student class was defined later the report, and report class being at the first, you're trying to access the student reference, again it will throw so many errors saying that it's not been defined. So yeah, this is the cleanest way and easiest way and tricky way to do it. Hope things are clear. Yeah, let me get back to the next. Uh, I didn't save it or what. Okay, anyways, fine. So this is done. Three or more operands. We got to know how to do it. And function overriding, let me open that. We were discussing function overriding under polymorphism, right? And was uh, function overriding. I think, is this the one? No, this is not the one. I'll come back to this later. This I have to save, I guess. That's why. Okay. What is this? Yeah. This was one of the example where we try to change, shape and rectangle Uh, in shape, there is just a print, and in rectangle, being a derived class of shape, we get length and breadth and try to print that, right? So we'll see uh, what output we got and how to debug that in function overriding. Students, you being very new to C++, I'm spending good time in showing how exactly to run and how to debug the things. So mm, hopefully in your lab, even this component has a lab part, you get enough time. So explore all possible things. Why it works like this? Why not in that way? Right? Whenever you practice, only you will get a control on the subject. So I can just run through some PPTs, but definitely you guys being at initial stage of your mm, engineering, you will miss the fun part of it. So I'm spending good time on this. So when I ran this function, or not a function, it's a mm, program on overriding, we got some garbage value, length into breadth. What is length? Before going to length into breadth, I will just quickly go through what is main function does. Main function takes an object of shape B and also rectangle uh, uh, object D of type rectangle. So both shape has a print area and rectangle has also a print area. So before going to this, what I will do is huh, b dot print area will definitely call this function. So it says nothing to calculate. We can write anything here, but just for our understanding, which function is getting called. Print area has been defined in both shape and rectangle. It will call the respective method itself until and unless there is a relation among these classes. Right now, there is a relation among these classes. What is that relation is? Rectangle being a child of shape. So it's a derived class. So when we already know that when we derive a class from its base class, now the base class is shape, and we derived a class called rectangle from base class shape, all its members, when I say members, attributes, methods, will be available in rectangle. So now definitely print area function is also there in this rectangle, but we are explicitly doing something else. When we want to do something else for this child class, we override that. We override what? Uh, for example, there is a print area method of base class is available in child class also. So when I say available, how to access that, we'll see that later. But right now I'm trying to override that. I don't want to execute these instructions which is available in rectangle. I want to do something else. So I have overridden it. Overriding the concept comes there, function overriding. We have overridden the print area function doing something else, so length into breadth. So if we closely look at the end, and yeah, it's giving a garbage error. So every time I run, it will give something else. See, I'm running this. I'm not even compiling it. I'm just running. Means uh, every time it gives some random numbers. Definitely, it's a garbage. Last class only I understood some garbage is picking it up. That is because, first of all, these values are not looked up. When I say length into breadth, length has some values, breadth has some values. It is trying to, because here length and breadth has some garbage values. This function is not at all called. That's why length is not having 10 and breadth is not having 20. Can anyone tell what is the problem here? First of all, it's a
It's a constructor, sir.
exactly it's a constructor, should not be a void. And when I try to run this, definitely we got an error saying rectangle some problem. That is because of typo. Look at this class name and look at this constructor name, right? So at the end of the last class, I quickly made it as void to remove that error, and it became a different function altogether. It's not a constructor. It has never been called. So construct, it is, first of all, it's not a constructor. It's normal method, and this never been called. That's why length and breadth doesn't have any value in this. So constructor calls at the initialization of an object only if the constructor and the class constructor function and the class name should be identical. So if I copy and paste here, right, now it will uh, do, it will work as we wanted. 10 into 20 is 200, right? So at the end of the last class, we just rushed, I mean, I just rushed to make that, and some, because of typo, we end up in garbage. Okay, this is one thing I just wanted to highlight about function overriding. Now, a few minutes back, I did told that this print area is also available in rectangle. Rectangle is not the rectangle is the correct. So every time, everywhere, I will just modify that, we get no error. Okay. So it's no error. Now I want to call a function that is base function at rectangle also. What I meant is, okay. So D is what? D is a object of type rectangle. When I say type rectangle, rectangle is a class. Like, uh, uh, for example, length. Length is a variable of type int. Similarly, D is a variable or an object of type rectangle. So if I do D dot, I will do a shape. It's a new thing. Print underscore area. So I haven't added a one more line in this. Hope it works. Yeah. If we see that, even though D being in a uh, derived class, still we are able to access its parent method. So because of this, right, derivation, this function is also available in rectangle. Now there are two methods of, say, print area. One is the actual one and the other one is the overridden one. So whenever we call d dot print area, the overridden will be called. Whenever we want to access the parent one only, then this is the way to do it. So hope the things is clear. It is that using this public access specifier, all the public things are available in rectangle also. So print area, two definitions are available, and one is nothing to calculate, and another one is to calculate the area of rectangle. So this method is the example of overriding the print area of the parent class. I think this can also be accessed. There is one. This is one way of accessing the actual method, means not the overriding method, the actual method, and you can access in another way too. So what I will do is uh, through pointer, how to access shape star. So pointer of type base class, some ptr, I will say ptr. Okay, and ptr will point to address of d. So is this clear, students? Any doubts, please ask so that I can revisit in detail. So what we did is we have taken a pointer. It can be some XYZ also, just for naming. Don't consider that just because I have initialized PTR, it's a pointer. XYZ is also a pointer. How it is pointer? Because a star. Star is a special operator which tells that it points to a one particular memory location. It doesn't explicitly has a memory, but it will point to the existing memory location. Okay, so for mm, easy readable, we are making it as to PTR. Now PTR is been declared, but it has to point somewhere. So right. So I made that PTR to point at the address of D. What is ampersand? It says the address. So wherever the object rectangle, right, is being allocated a memory, that particular address this pointer is referring to, means pointed to. Now this pointer, even though of type shape, it is pointing to, you know, object D memory. So I think this is PTR. How to call now? It's pointing to D, and print area. I guess this should work. If not, we'll see. See? So this is one way of accessing using a resolution operator, right? With uh, both are being called from the child class. This is the most important thing. We saw, couple of outputs here. Say nothing to calculate, nothing to calculate, and nothing to calculate three times. The first one is called from base, so we doesn't have any problem in that. Base definitely it will point to here and it will call. And we have a in child also. I mean, when I say base, it's a parent. Even in child also, there is a print area. Got it from its parent, as well as it has been overridden also. So when we blindly just call d print area, the overridden function is called. But if we want to call which the child got it from parent by default, if we want to call that, there are two ways to do that. One is through resolution operator, and the another way of through pointer. So we just saw live, like uh, how to call the methods, uh, mm, which got from its parent class, and how to override those also. After overriding also, we can still look back and get the default function. This is the default function which is already available in child, because we have derived the rectangle class and from shape using public access specifier. Right? Any questions, students? Any questions? Just quickly move to the window. Any? Oops, I'm not in this now. I'm in this. Any questions on?
No, sir.
Yeah, can type here. This will be a good way of acknowledging. Acknowledging.
ഒന്നേനെയാണ്
Someone is and can you please mute?
ഒന്നേ
Okay. Hmm. Okay, great, thanks. So yeah, coming back to, we saw function overloading and operator overloading concepts are pretty clear. We saw good examples, we saw good assignment also, and now function overriding, we saw the how things works. Function overriding, and function overriding is it's runtime. It never understand at compile time. this, calling the respective function, this happens only in runtime. That's why it comes under dynamic polymorphism, static polymorphism, dynamic polymorphism, or compile time, runtime. These are the synonym modes. And yeah, uh, we quickly go through the same thing which we saw in an example, C++ example. There is a base and derived. We saw this in the last class, and then we try to change this from base derived to shape and rectangle, right? So the output will be derived function because it is derived. One is an object from derived, that is this child class, and its print. Definitely this will be printed rather than this. So it points to this rather than this, even though this definition is also available in the derive, but instead of that, this will be called because programmer has overridden that default thing. So function overriding, to access the overridden function of the base class, we use the scope resolution operator. We saw an example for that, right? And we can also access the overridden function by using a pointer of the base class to pointing to an object of the derived class. So we took an object, right? Sorry, we took a pointer of base class, and we made that point to the derived class, and still it is pointing to derived class and could able to access the default method, not the overridden method, right? uh, and then calling the function from the pointer. Yeah, there are two ways to do that. We saw in an example. This is the quick same thing, base and derive. uh, Now derive to dot base with print. Base is the uh, parent class name and the resolution operator. So it gives derived function as well as base function. Yeah, even though both the objects are type derived, it points to the this overriding functions and overridden function. And through using pointer, this is again a C++ example using pointer. So we took a pointer of type base, and then we made that pointer to point to an address to a child class, and using that pointer can access the default function using this operator, right? And it gives base function rather than the derived function. This print will give base function, the default function. So a minute is more. So quickly to see, what is function overloading and overriding, we'll try to put some concepts together and compare it. So with respect to inheritance, overriding of function occurs when one class is inherited from another class. So the overriding concept comes only with respect to inheritance, right? But overloading can be done without inheritance, or can occur without inheritance. Same class name, same function name. There should not be any relation, something like that. So this is one thing. And next is function signature. Overloading functions must differ in function signature. Overloaded functions, like we saw, if we pass one parameter, two parameters, three parameters, four parameters with the same name, and the parameter either one, if two functions having same function name but having same parameters, the number of parameters are same but differs in their data type, then also the function overloading works. So that part is called a function signature. So overloaded function must differ in function signature, but in overriding, function signature should be same, must be same. It must be same. Right, that's why when students went for no, that is a different thing. That's operator overloading. Yeah, we are talking about function already. And coming to the next point, scope of functions. Overridden functions are in different scope because of inheritance, and whereas overloaded functions are in the same scope. That's a true behavior of functions. Overriding is needed when derived class function has to do some added or different job than the base class function. Overloading is used to have same name functions with different situations depending upon the parameters passed to them. Just to have a quick comparison, it's nowhere comparison, but as the name says, function overloading and overriding is quite similar. I thought of putting the available concepts together, and we'll see how things goes for function overloading and overriding. Most same things I put it in the table also. Yeah, so I will. It's 9:50. So today I will complete the polymorphism thing, and in the next couple of class. So let me quickly go to the syllabus. So we almost covered concepts, classes, objects, what all the methods are used, how to pass the messages, like how to assign to the attributes, member variables, abstraction and encapsulation. We saw inheritance at a higher level because there is one more unit called inheritance and polymorphism in detail. We'll look with the examples too. Right now, inheritance, we had just touch based what is with respect to introduction, abstract classes, polymorphism. In this polymorphism, function overloading and operator overloading, and also function overriding. We saw C++ fundamentals, like how to define a C++ program, what is namespace and IO stream, libraries and things like that, C in, C out. But yeah, with respect to those fundamentals, we'll look for IO operations also. We saw already constructor, destructor, and also quick few example of point using pointers too. Only the left part is IO operations and string handling. Will in this probably this week we'll try to finish this whole unit one, and we'll get into the next unit, right? So yeah, that's all to convey in this class. We'll see you in the next class. Thank you, guys.
Thank you, sir.